Welcome, Chaks Solution. This is inequalities. Alright, so our first thing here, we are going to be dealing with quadratic inequalities here. So we have steps that we follow when you are solving quadratic inequalities, right? So the first thing here, the first step is to rearrange the inequality such that the right hand side of the inequality is 0 here. Alright, then second step, solve the corresponding quadratic equation to find the critical values. Then the third step here, arrange the critical values using the inequality boundaries or the regions here. Then the final step here is to test the boundary to see the true region here. So let's just look into the example and demonstrate these steps here so that you can see what we are talking about here. Alright, so solve the inequality 2x squared minus 11x plus 12 is greater than 0. So you can see this is a quadratic inequality. Why? Because this is a quadratic expression on the left hand side. So that quadratic expression on the left hand side is greater than 0 here. Alright, so we need to check here whether on the right hand side here we have 0. So this is the 0 that we have on the right hand side. Everything is on the other side, which is the left hand side here. So now we need to solve for this expression to find the critical values. So we are going to equate the left hand side here to 0 here. So it's 2x squared minus 11x plus 12 is equals to 0, such that we can find the critical values. Alright, so we can solve this quadratic equation either by using the quadratic formula or method of completing square, or we can use factorization if possible. Alright, so in this case we can see it's possible to factorize here, because 2 times 12 here is 24. So 24, we can have two factors that can be multiplied to give us 24 and give us minus 11 here. So those factors are minus 8 and what? And minus 3. So it's going to be 2x squared minus 8x minus 3x plus 12 is equals to 0 here. So we can factorize this one as 2x open brackets x minus 4 close brackets minus 3 open brackets x minus 4 here equals to 0. So it's 2x minus 3 open brackets x minus 4 is equals to 0 here. So now we can now find the critical values here. So the critical values are x is equals to 3 over 2 or x equals to 4 here. So now we need to arrange the critical values using the inequality boundaries here. So you can see the smallest critical value that we have is 3 over 2, and the largest one is x is equals to 4 here. Alright, so when you're writing here, you start with the smallest one. So it's x less than the smallest critical value. So it's x less than 3 over 2. Then the next boundary, we are joining the smallest one. So it's 3 over 2 less than x less than 4 here. Then the next boundary is going to be x greater than 4 here. So these are the boundaries that we have. So you start with the smallest one, so it's x less than 3 over 2, and then 3 over 2 less than x less than 4 here, then x greater than 4 here. So now we want to see which of these regions satisfy this inequality. So we are going to test this region and also test all this region here. Alright, so let's see how are we going to test it. Alright, so we are going to use this inequality 2x squared minus 11x plus 12 greater than 0 here. So this is the inequality that we are using, where we have on the left hand side we have our quadratic expression, and on the other side is now what? 0. So we use this one, right? So it's 2x squared minus 11x plus 12 is greater than 0 here. So we are going to test the first region. So the first region that we are going to test is the region which is less than 3 over 2 here. So we want to test for whether this region will satisfy the inequality. So it's x less than 3 over 2. So we take a number which is less than 3 over 2 here. So the number which is less than 2 over 3, we can use 0 here. Alright, so we place 0 into this inequality. So we're going to see it's 2 0 squared minus 11 times 0 plus 2 here. So you can see 12 is greater than 0 here. So 12 greater than 0 is true. So which means this region is what? It's true here. Alright, so now we go to the next region that we are going to test here. So this one we are testing for 3 over 2 less than x less than 4. So we look for a number which is between 3 over 2 and 4 here. So the number is 3. So we place 3 into this inequality here. So you can see it's 2 open brackets 3 squared minus 11 times 3 plus 12 here greater than 0. So you can see it's minus 3 is greater than 0. So minus 3 is greater than 0. It's a false statement here. So which makes this region to be what? To be false. The second region to be false here. Alright, then now we are testing the next region. So it's x greater than what? Greater than 4 here. So we need a number which is greater than 4 that we test into the inequality. So we can take x equals to 5 here. So we just place 5 here. So it's going to be 5 squared minus 11 times 5 plus 12 greater than 0. So you can see we are going to have 7 is greater than 0. So this statement is true here. So it's 7 greater than 0. So the statement is true. So which makes the region which is greater than 4 to be true here. Alright, so this thing, this part when we are testing here, you can just press your calculator. You can just press your calculator and you'll be writing true or false by just pressing on the what? On the calculator here. Right, so now we notice that this one, the region of x less than 3 over 2, united with the region of x greater than 4 here. These are the two regions that are satisfying this inequality. So which means therefore the set of solution is x less than 3 over 2 union x greater than 4 here. Alright, so let's go to the next example here. Solve the inequality x minus 3 squared greater than 2x plus 1 here. So the first thing we said, we have to take everything to one side here so that we have the 0 on the right hand side. Alright, so in this case we first expand here, so it's x squared minus 6x plus 9 after expansion here, then greater than 2x plus 1 here. Then we take everything to one side. We are going to have x squared minus 8x plus 8 greater than 0 here. So now we want to find the critical value by finding the corresponding solution for this quadratic expression here, x squared minus 8x plus 8. So instead of putting the inequality sign, we are going to put 0 so that we can find what? The critical values. So finding the critical values is x squared minus 8x plus 8 is equals to 0. So how are we going to find the critical values here? We say either you use method of completing square or method of factorization, or finding what, or use the quadratic formula. So in this case we are going to use the quadratic formula here. So x is equals to minus b plus or minus 8 squared minus 4ac all over 2a here. So this will give us x is equals to 4 minus 2 root 2 or 4 plus 2 root 2 here. So now we have these two critical values here. So now we go with these critical values on the table that we have. Right, so this is our table. So we start with the smallest one. So the smallest critical value here is this 4 minus 2 root 2. So it's x less than 4 minus 2 root 2. Then we go to the next one. We join 4 minus 2 root 2 less than x less than 4 plus 2 root 2. Then the last one is x greater than the largest critical value 4 plus 2 root 2 here. So now we are testing for the first region, second region, and third region here, so that we see which one is true here. Alright, so how are we going to test? So we are going to use this inequality where we now have 0 on the right hand side here. Alright, so we are testing here. So first region, testing for x less than 4 minus 2 root 2 here. So any number that is less than 4 minus 2 root 2 here is 0 here. So we are going to use 0. So you can just press this number on the calculator so that you can see the approximate value. Right, so you can now use x equals to 0 here into this inequality. So you see that it's 8 greater than 0 here. So x 8 greater than 0 is a true region. So this make this region to be what? To be true. Alright, so now we test for the next region here. So the next region is 4 minus 2 root 2 less than x less than 4 plus 2 root 2 here. So we need a number between 4 minus 2 root 2 less than x less than 4 plus 2 root 2 here. So you can use x is equals to 4. So we are using x is equals to 4 into this inequality here. So you see that it's 4 squared minus 8 times 4 plus 8 greater than 0 here. So this will give us minus 8 greater than 0. So this is false. This is a false statement. Minus 8 greater than 0 is a false statement here. Right, so this region is false here. Then we test the other one, x greater than 4 plus 2 root 2 using x equals to 7, a number which is greater than this value. So we put 7 into this inequality here. So you see that we are going to have 7 squared minus 8 times 7 plus 8 greater than 0 here. So 1 greater than 0 is true here. So we're going to have 1 greater than 0, so it's true. So this statement is true. So this will make this last region to be true. So now we are combining the two regions here. So which means we are going to have x less than 4 minus 2 root 2 union x greater than 4 plus 2 root plus 4 plus 2 root 2 here. Right. Right, so let's go to this one. Solve the inequality 2x open brackets x minus 6 less than or equals to 7 here. So you can see we need to expand this part and take 7 to the other side here. So it becomes 2x squared minus 12x minus 7 less than or equals to 0. Alright, so now we want to find the critical value. So this part 2x minus 12x minus 7 is equals to 0. So we can use the quadratic formula or completing squares. So in this case, let's just use the quadratic formula. So it's going to be x is equals to 3 minus 5 root 2 over 2 or 3 plus 5 root 2 over 2 here. So you can see this is the smallest critical value and this is the largest critical value. So now we go on the table value and we need to test. So we start with x less than or equals to 3 minus 5 root 2 over 2. Then the smallest critical value less than or equals to x less than or equals to the next critical value, this one. Then x greater than the last critical value, our large critical value. So you can see here there is or equals to or equal to here. We are also taking from the sign here, we're using less than or equals to here. So here also when we are joining our boundary, we use or equals to here. Alright, so now we are testing these three regions that we have. Alright, so we test using this equation where we have on the right hand side there's a 0 here. So we test the first region. So it's x less than the smaller critical value. So any number that is less than this value is x is equals to minus 1. So we place minus 1 here. So it's going to be 7 less than or equals to 0. So this is a false statement. So this make a region false here. Alright, then we go to the next region here. So the x value that is between the smaller critical value to up to the larger critical value here is 0. So we place 0 here into the inequality sign, into the inequality here. So we're going to see that minus 7 is less than or equals to 0. So minus 7 less than 0 is a true statement. So this make this region to be what? Be true. Then you go to the last region here, x greater than or equals to 3 plus 5 root 2 over 2 here. So we take a number which is greater than this value. So we take x equals to 7. So we substitute into the inequality here. So we're going to see that is 7 less than or equals to 0 here. So which makes this statement is false. 7 is not less than 0. So it's a false statement. So this part is what? Is false. So now we are writing our solution. So the set of solution is 3 minus 5 root 2 over 2 less than x less than or equals to x less than or equals to 3 plus 5 root 2 over 2 here, because this is a true what? True region here. Alright, so thank you for watching the video. See you in the next lesson.